A pretty common question on this SAT exam is when they give you a circle and then they give you a shape inscribed in the circle. In this case, let's use a square as an example. They'll give you the length of one of the sides of the square. Let's say that that's equal to 4. And then they're going to ask you to find the area of the circle. So what do? Well, anytime you have a circle and you have something inscribed inside it, first thing you should always do is to find the center. From the center, connect the center to all the vertices. In this case, we have the 4 corners of the square. And what do each of these dotted lines represent? Well, each of these represents a radius, right? And what do we need to find the area of a circle? Well, the area of a circle is pi r squared, so we need to figure out what the radius is. So that's basically our job. We need to figure out what this radius is. So I'm going to redraw the square, and I know that from the center to one of the vertices, this is the radius, and that's what I need to figure out, given that one of the sides is equal to 4. Well, since I know that this is a square, and I know that if I draw the full diagonal, this becomes a 45, 45, 90 right triangle. I can use the ratios of the sides of a 45, 45 right triangle and say this is 4, 4, and 4 root 2. But I want the radius, which would only be half of that. So the radius would equal the diameter divided by 2, or in this case, 4 root 2 divided by 2, which would be 2 root 2. Now that we found the radius, we can apply that and plug that into the area equation for a circle. So it'd be pi 2 root 2 squared, that whole thing squared, and this whole thing squared would be 4 and then 2, so we get 8 pi as our final answer. So it really doesn't matter if what's inscribed is an equilateral triangle or say a rectangle. Again, the first thing that you should always do is find the center and connect all the lines or all the vertices with that center, because all of those represent your radius, or they all become your radii. Now it doesn't matter if they're asking you for the area of the circle or they're asking you for the circumference of the circle. Regardless, we're required to figure out what the radius is, right? That's our main objective. And so that's why we always want to draw the vertices, the lines connecting the vertices to the center.